Hi everyone, in this video I'd like to talk about the first derivative test. So I've given you a graph, and the graph I've given you here is of f prime. So this is a graph of the derivative. And from the graph of the derivative, we want to infer some properties about f, like the critical values and where is f increasing or decreasing and so forth. So what I recommend doing is going from the graph to a sign chart. If you try to go from the graph of the derivative all the way over here to the critical values, it's kind of a big leap, and sometimes you can get a little bit twisted around. So let's just go according to the definition and first principles. So I'm going to make a sign chart. And the only interesting value here going on is 3. So I'm going to put that here. And this is the x value when x equals 3. Now, I've got some information about f prime, and then that's going to allow me to infer some information about f. So f prime, what do we know about it? Well, we know that f prime is 0 when x is at 3. And then when x is beyond 3, when x is greater than 3, we see the first derivative is up here above the x-axis. It's a positive value. And then over to the left, or less than 3, we see that the first derivative sits below the x-axis. So these are all negative values down here. What does that tell us about f? Well, we know that when the derivative is 0, we have a flat spot on our curve. So I'll just make it a little flat spot there. Because the slope is 0. It's like if you were standing on a level road or a level ski slope, you wouldn't be going up or down, you'd be flat. And what else do we know? We know that when slope is positive, or f is increasing, so slope is positive, we're going uphill. And when the slope is negative, if you think back to algebra and pre-calculus, when you had like a slope of -10, the line was going downhill when we look from left to right. So I can see right now the general shape of f. It's going down until I hit x equals 3. There's a flat spot, and then I'm going back up. So that makes it easy for me to talk about critical values. That's when the first derivative is 0 or undefined. So we've got a critical value at x equals 0. F is increasing from 3 to infinity. It's decreasing from -infinity up to 3. I'm using the parentheses there because I'm not landing on the 3. Now, where's their relative max or relative min? You can go back to the definitions in the book, and it's very technical, but you can also just look at the picture. It looks like I'm at a low spot or a relative min here at x equals 3. Now, it's not that the minimum value is 3. It occurs at x equals 3. I don't know what the y coordinate is there, so I don't really know what the relative min is, but I do know where it occurs. And relative max does not exist. Okay, let's do the same problem, but let's crank it up a notch and look at something that's a little bit more complicated. So I'm going to look at a graph that looks like the following. Make some space for us here. Now get rid of our sign chart. Okay, we're good to go. So for our next function, let's take a look at one that's a little bit more complicated. So I'm going to look at the graph of the derivative. And we've got some interesting points on here. They occur at 0, at 1, and at 2. And my derivative looks like this. And again, this is a graph of f prime. So to figure this out, I'm going to go again with my sign chart. I'm going to make a x number line. The only interesting values are x equals 0, x equals 1, and x equals 2. And I know something about my first derivative. So at those values, it's 0 because it's the line is crossing the x-axis then, so I know that f prime is equal to 0 when x is 0. It's equal to 0 when x is 1, and similarly when x is 2. Now, over here, when x is less than 0, I can see that that f prime curve is sitting up high in quadrant 2 there. It's got positive values. It then dips down below, so it's got negative values. Again, we're dipping up. Now we're in quadrant 1, so those y values, those f prime values are positive. And again, we dip down below. So I've got a few flat spots on my curve for f, and I've got some places where it's increasing, flat, decreasing, because I'm going downhill with a negative slope, flat, increasing, flat, decreasing again. So this time I've got 3 critical values, x equals 0, 1, and 2. Where is it increasing? So I'm going uphill, or I have a positive first derivative. So you could write this f prime of x is greater than 0 for the following intervals. Or my curve is going uphill when I'm on the interval negative infinity to 0. Also from 1 to 2. I'm going to write union 1, 2. It's decreasing. In other words, my first derivative is negative when I'm between 0 and 1. Again, I'm using the parentheses. It's the open interval from 0 to 1. Union open interval to infinity. Relative max, well, there's actually 2 of them, and they occur at x equals 0. There's one, and there's another peak of a mountain over here at x equals 2. Again, I don't know which one's the absolute max. You know, one of those peaks is going to be higher than the other when I actually have more information about f. But right now, I just know that there is a peak. I just don't know which one is the absolute max. And then in terms of minimums, there is a relative min at x equals 1. And let's just clarify, it's at x equals 1 because I don't want to say the relative min is 1. It's not like my min value is 1. I can't be that bold. I can only say it occurs at x equals 1. And then obviously the function is just going to trail down. So there's going to be no absolute minimum because it's trending down, down, down. But there is going to be a little dip in the valley right there when x equals 1. So I do have a relative min. All right, let's do one last tricky example and then we'll call it a day. So for this one, let me just make a little space. These are actually kind of fun. At least I'm a very visual person. So, you know, for me, when I'm working on these and when I took Calculus 1, you know, a million years ago, because I'm a bit of a dinosaur now, when I took Calculus 1 as an undergraduate student and back in high school, I remember making these sign charts. So, you know, you can go strictly by the definition and say, okay, when is the derivative greater than 0 or when is the derivative less than 0? But it's really easy to get twisted around unless you make a sign chart. At least that's the way I proceed, but you might be different. So here's my graph. I've got a lot of interesting points this time. So let's be very careful how we draw this. So I'm going to go up through 1, 2, 3, 4, 5. And then over here on the negative side, I'm going to be going down -1, -2, and let me extend a bit more to -3. And my derivative curve kind of looks like a big M shape. So let me connect the dots with myself. So I'm going to go here. I'm going to connect those. So I'm going to come up, touch down, and then I've got another peak over here above 4, and I'm going to cross the x-axis at 5. And again, this is the graph of the first derivative. So let's make our sign chart. I've got a lot of interesting points to keep track of here. The first of which is -3. Then I've got another critical value at 1. Another critical value at 5. Now, you might even be so bold as to go in and think about what the second derivative would look like and see if you could infer something about concavity. I won't cover that in this video, but that would be an extra challenge if you're up for it. Anyways, we've got 3 critical values because our first derivative is 0. It's 0. It's crossing the x-axis at those 3 spots, -3, 1, and 5. So we've got critical values at -3, 1, and 5. Now, when I'm less than -3, my first derivative sits below the x-axis. I'm down here in quadrant 3, is sitting down here in the negative values. Then I'm up above the x-axis, so it's positive until I hit 1, then it's 0, then it's still positive. That's kind of interesting. And then I go up and around, I hit 5, it's 0 again, and then we're going to be negative. So what's going on? If I were to try to draw the behavior of f, and again, this is really a rough estimate, but I'm going downhill, so negative slope means I'm going downhill. I hit a flat spot. Now I'm going uphill. I'm going to hit a flat spot, and then I'm going to go uphill again, hit a flat spot, and go down. So, sometimes you're hiking and you're going up a hill and then you get a little breather because it gets flat and then you keep going up the hill. That's kind of what we've got going on there. And if I were to actually try to draw what that looked like, maybe I'm going downhill, and then I'm going uphill, and I'm flat, and I keep going uphill, something like that. This is a really crude drawing, but get the idea. In terms of when f is increasing, so when is the slope positive, I would say it's increasing from -3 to 1, union 1 to 5. It's decreasing from -infinity to -3, union 5 to infinity. Relative max at x equals 5. And we see that peak right here. It's like a little mountaintop. This just looks like a flat spot in the road, so that's not really anything too exciting at x equals 1. It's just a break or a breather on our hike. But there is a relative min over here at x equals -3.